Hello, Algebra 2, and you have made the very wise choice to come and watch the Chapter 2 review video. I'm going to be doing 9 problems with you, and here's the deal. If you write down every problem neatly with emphasized instructions and bring this to class on test day, you will receive 8 points extra credit. So this is a golden opportunity for you to be extra prepared and reap the benefits of wise preparation. So just putting that out there, and I won't be saying it in class and I won't be writing it anywhere. So you're only going to get that info from this video. So let's get started. So first of all, we're going to be solving this absolute value equation. And step 1, if you remember, is to isolate the absolute value. We want to isolate the absolute value. So to do that, I need to start by subtracting the 7. And that gives me -4 times absolute value of x plus 5 equals x minus 4. Then from here, we want to divide by -4. And remember, everything's getting divided by -4. So that cancels, and we get the absolute value of x plus 5 is equal to, now this is a tricky fraction, but you can do it. It is -1/4 x. And then, of course, -4 divided by -4 is a plus 1. So we did step 1, which is to isolate the absolute value. Step 2 is to write 2 cases. So we're going to write 2 cases, and it's going to turn out to be this. This is an OR situation. X plus 5 equals, just as it's given, or the negation of the right-hand side. X plus 5 equals -1 times -1/4 x plus 1. So step 3, of course, is just to solve. We're going to solve both of these equations now. So what do we have first? Well, first, let's get rid of that fraction. And to get rid of that fraction, we just want to use the common denominator. There's only one fraction, so we can deal with that. Let's multiply both sides by 4. So this will be 4x plus 20 equals, and I am distributing, -1/4 of 4 is -1, so -x, and then 4 times 1 plus 4. So next, let's add x, 5x plus 20 equals 4, minus 20 minus 20, 5x equals -16, divide by 5, x equals -16/5. Don't be intimidated by fractions. Just learn to love them. We're going to do the same thing over here, but first we got to distribute that -1. X plus 5 equals +1/4 x minus 1. Now, same thing we did. Get rid of the fraction by multiplying by 4. So 4x plus 20 equals x minus 4 minus x minus x. 3x plus 20 equals -4 minus 20 minus 20. 3x equals -24. No fraction on this side. X equals -8. Now, it would also be wise to take your answers and plug them back in all the way back at the beginning, because we want to check and see if we have any extraneous roots. I'll let you do that on your own to save time. Next problem. If a sub 24 find a sub 24 if, I was right to begin with, my bad. Find a sub 24 if a sub 10 equals 20 and d equals -3. Remember what we're given here. So we do not know the first term, but we do know the d. Remember, the d value represents the common difference. The common difference in the arithmetic sequence. and it's negative 3, which means that our sequence is not increasing, but it is getting smaller by 3 every move that we make. So if we think about a sub 10 is equal to 20. If the common difference is negative 3, then a sub 11 is going to be 17. A sub 12 is going to be 14. ... So we want to, let's find a sub 1 by using a little multiplication. So if the common difference is negative 3, and we know a sub 10 is 9 behind a sub 1. So if we say 10 minus 1, we get 9. And we multiply that by the common difference, we get negative 27. So we can use this 27 and we can backtrack. Remember, the common difference is negative, so the sequence is getting smaller going forward. So going backwards, it's going to get bigger. So what we need to do is add 20, which is a sub 10, with 27, which is what we get when we say 9 times negative 3, and we find our a sub 1 value is actually equal to 47. So a sub 1 is equal to 47. And if we have a sub 1 and we have d, then we can write the general rule for this sequence. Now, this is something that I ask you to memorize. A sub n equals a sub 1 plus n minus 1 times d. I ask you to memorize this. This is the formula for finding any term in an arithmetic sequence. So a sub n equals a sub 1, which we just found, 47, plus n minus 1 times the d. The d, of course, is negative 3. Note my use of parentheses. So this is the general rule. This is the general rule for finding any term. So if I want a sub 24, I am going to plug in 24 for n. So a sub 24 equals 47 plus 24 minus 1 times negative 3. So a sub 24, remember once again, our common difference is negative. Our sequence is getting smaller by 3 every time. So a sub 24 is 47 plus 23 times negative 3. 23 times negative 3 is negative 69. So 47 plus a negative 69. 69 minus 47 is 22. Negative 22. So a sub 24 is negative 22, which makes sense because once again, if our common difference is negative 3, our sequence is getting smaller by 3 every time. So 24 jumps down the line, we will be at negative 22. This is the answer, but this is the general, this is the formula, and this right there is the general rule. Let's do it again. This one's a little bit different because this time I'm giving you a sub 1, a sub 2, a sub 3, a sub 4. So first thing we need to find is what is the d? Well, our sequence this time is getting bigger. It's getting bigger by 5. 8 minus 3 is 5. 3 minus negative 2 is 5. So the common difference is a positive 5 this time. So let's find the general term or the general rule, which is finding a sub n, and then we'll find a sub 30. So here it is again, what I ask you to memorize. That's the formula for every arithmetic sequence that has a common difference. So a sub n equals a sub 1, which is negative 7, plus n minus 1 times the d, which is 5. So this is our general rule for this particular arithmetic sequence. Therefore, we're going to find a sub 30. So we will let n equal 30. A sub 30 equals negative 7 plus 30 minus 1 times 5. A sub 30 equals negative 7 plus 29 times 5. 29 times 5 is 30 times 5 minus 5, so that's 145. Negative 7 plus 145, a sub 30 is positive 138, which makes sense because our sequence is getting bigger by 5 every single step of the way. Moving back to absolute value, so solve and graph. If we're going to solve and graph here, we're still going to follow our steps, isolate the absolute value, which is already done for us. So we can go right to step 2, which is write two cases. 2x minus 6 is less than 4. Ooh, less than, everybody, less than. This is an and situation. 2x minus 6 is less than 4, and 2x minus 6 is greater than negative 4. Remember, this is the negation, so we will flip the sign and change the sign of the entire right side. So now we're going to solve. So plus 6, 2x is less than 10. Divide by 2, 2x is less than 5. Plus 6, 2x is greater than 2. Divide by 2, x is greater than 1. Yes, this is an and situation. Less than. Add that D on the end. So this is a less than situation. So what are our answers? Because we're going to graph them now. Our answers are less than 5 and greater than 1. So this is an in-between situation. There's 1, there's 5, open, shade everything in between, because we'll put 3 right in the middle here. Is 3 less than 5 and greater than 1? Yes. So that is our solution set. Okay, we're about halfway done. Next, we're going to solve this system. And I think we should solve this system by substitution, because I can so easily solve for that x with just one move. So we will take that negative 3y from the left to the right and get x equals 5 plus 3y. So now that x value is going to go in right there. We will substitute it in. Negative 2 times 5 plus 3y plus 6y equals negative 10. Distribute. Negative 10 minus 6y plus 6y equals negative 10. Ladies and gentlemen, we are ending with a true statement. And when we end with a true statement and no more variables left, we know that there are infinitely many solutions. Why? Because basically these two equations are representing exactly the same line. So those lines are on top of each other. They're called coinciding. All of their points are shared. Next, number 6. Again, let's solve this one by substitution. It's set up for substitution. It's ready to go right there. X is 3 minus y. So we're going to plug that in to that x right there using the substitution property. So 4 times x minus 2y equals 36. Use the distributive property. 12 minus 4y minus 2y equals 36. Combine like terms. 12 minus 6y equals 36. Minus 12. Minus 12. I'm just solving for y. Negative 6y equals 24. Divide by negative 6. Y equals negative 4. There's my y value. Am I done? No. Still need to know x. X is 3 minus y. Y is negative 4. 3 minus negative 4. Go ahead and change that minus a negative to plus a positive. X equals 7. So I want to see your answers in the form of a coordinate, x comma y. That is 7 comma negative 4. That's the solution to the system. That's number 6. Next, we've got a system that has us solving for x, y, and z. Now, the only way we can do this is to use elimination. And make a plan here. So I see some wonderful things that are going to happen here, and just like we did in class, we'll let this be A, this be B, this be C. So it looks like we should go after the Y's or the Z's. They are the easiest ones that are going to cancel because, of course, we are looking for opposite coefficients. Opposite coefficients. That's what we want to see. And I see opposite coefficients on the Y's here and also on the Y's here. So let's go for the Y's. So let's add A plus B, and the Y's are going to cancel pretty easily. So 3x plus y minus z equals 1. X minus y plus z equals negative 3. Remember, we always want to add. That keeps us from having to deal with negative signs. It's always the best bet. 3x plus 1x is 4x. Positive y and a negative y cancels. Negative z and a positive z cancels brilliantly. 1 and a negative 3 is a negative 2. So we end up with 4x equals 2, divide by 4, x equals negative half. Now, we're getting a fraction, but don't panic because it's a very easy fraction. It's just a half, no big whoop. So we added a plus b. Remember, we want to go after the same variable again, so we're going to go after the y again. This time we're going to do b plus c. So b plus c, x minus y plus z equals negative 3. 2x plus y plus z equals 0. Ready to go with our opposite coefficients. X plus 2x is 3x. The y's cancel. Z plus z is 2z. And negative 3 plus 0 is negative 3. Now, the good news is we don't have to do elimination again because we already know x. X is negative half. So we can make that substitution right there and get 3 times negative half plus 2z equals negative 3. So now we've got 3 times negative 1/2 is negative 3 over 2 plus 2z equals negative 3. So we're solving for z, so I am going to add 3 halves to both sides and get 2z equals negative 3 plus 3 over 2. So negative 3 over 1 times 3 over 2, if we get a common denominator of 2, we end up with negative 6 over 2 plus 3 over 2. So when we solve here, we get 2z equals negative 3 over 2. Divide by 2, divide by 2, and this one is for all the people in the room who love to divide by a fraction. So negative 3 over 2 divided by 2 turns into multiplication by the reciprocal. So we find z to be negative 3/4. There's x, there's z. Now we know x, now we know z. We want to go all the way back to the beginning and choose an either A, B, or C. It doesn't matter. I'm going to go with C because we haven't done much with it yet. We're going to find out y. 2x plus y plus z equals 0. So now, x equals negative 1/2. 2 times negative 1/2. Plus y plus negative 3/4 equals 0. Negative half of 2 is negative 1 plus y plus negative 3/4 equals 0. So we need a common denominator. That -1, I can transform it into -4/4 in order to have like terms. So that is going to be -7/4 plus y equals 0, y equals +7/4. So we get a final answer of x, y, and z of -1/2, +7/4, and -3/4. Final two problems. Thank you for hanging in there through this video. We're going to graph and shade 3 inequalities, and then we're looking for not just what's doubly shaded, but what is triple shaded in order to find our solution set. So, first equation here. First equation is 5x minus 6y equals, and just to make this a little easier on ourselves, I'm going to change that to 18 right there. There we go. So 5x minus 6y greater than 18. So let's solve it for y. So minus 5x minus 5x, -6y is greater than -5x plus 18. So from here, we are about to divide by a negative all the way across. And I'm going to move my work down here since I'm running out of room. The 6's cancel. We get y is now less than -5 over -6. That fraction's just our slope. And 18 divided by -6 is -3. There we go. So now we're going to graph this. It's going to be strictly broken, that line. So -3. Remember, the slope is the rise over the run. So up 5, 1, 2, 3, 4, 5 over 6, 1, 2, 3, 4, 5, 6. And now we can graph that line. We can graph that line and use a straight edge just so your work is nice and neat. Remember that it is a broken line. And then we're going to try a test point. There we go. So there's our first inequality. So go back to what was given. So plugging in 0, 0. So 5 times 0 is 0. 6 times 0 is 0. Is 0 greater than 18? No. So that means we will not shade to include 0, 0. So just do your shading lightly to begin with. Now let's draw x is less than or equal to -2. That, ladies and gentlemen, is a vertical line at x equals -2. So it's over here. Going back to my handy dandy note card as my straight edge, this time it's going to be a solid line because of the or equal to. So there it is. And plugging in 0. Is 0 less than -2? Is 0? No, 0 is not less than -2. So are we going to shade to include 0? No, shade in this direction. So here we go. Down at the bottom, this is our overlap so far. Last line, y is less than -3 or +3. So horizontal line at, once again, +3, right there. And this one is going to be broken. So actually, I better not do it in orange. Probably need a new color. Let's go, I don't have a green. We'll use this green. So here we go. Once again, broken line at 3, right here. And is 0 less than 3? Yes, so we are going to shade below that line. So what are we looking for? We're looking for where the shading is all overlapping. And it is going to be only in this little smidgen right down there. That is where the graph's shading all overlaps. Let's do it again, this time with only 2 lines. Last problem, -x. What are we doing here? We are solving for y. We want to solve for y to get it in slope-intercept form. Y is greater than negative x plus 2. This one's simple to graph. Y-intercept at 2, a slope of negative 1, down 1 over 1, down 1 over 1, down 1 over 1. This graph will be broken because it is strictly greater than. So there's my graph for the first one. Let's plug in a 0 here and a 0 there because 0, 0 is our test point. Is 0 plus 0 greater than 2? No, it is not. Therefore, we will shade up because we do not want to include 0, 0. Next, 3x plus 3y is less than negative 6. Solve it for y. Solve for y in order to see the slope in the y-intercept. 3y is less than negative 3x minus 6. Divide by 3, divide by 3, divide by 3. Y is less than negative 1x minus 2. So we have parallel lines. We have parallel lines because we have, ladies and gentlemen, the same slope. These lines are rising and running at the same rate. So they're never going to cross, but let's get it plotted and see which way the shading is going. Y-intercept is at negative 2. Slope is the same. This time it is still broken because it is strictly less than. So once again, plug in 0, 0 is 3 times 0, which is 0, plus 3 times y, which is 0. So is 0 plus 0 less than negative 6? No, it is not. So we are going to shade away from 0, 0, and we find that there is no overlapping shading here. So there is no solutions. And that, ladies and gentlemen, is the end of this review.